Hello, good morning, everyone, and I'm here to give you a virtual tutorial about the virtual lab activity number 5 task that you have to complete today. Some of you have started completing it yesterday, but for some who have not attended the live instruction and who didn't know how to do it, I prepared a virtual tutorial for you to complete so that you will be guided as you follow through the steps. So the first thing is you're going to go to Canvas and you have to click on the assignment, and you will see here virtual activity tab where virtual activities for this second 9 weeks will be found. And the first thing in the line, which is part of your interim report grading, is the virtual lab number 5. Virtual lab number 5 is all about earthquake. And this activity will be requiring you to perform the necessary steps to obtain a certificate at the end of the entire procedures. So you will be using this link. You're going to go ahead and click that, and you will have to turn in the certificate to me through the following ways, either through this form turn in or through email, or just turning it in on the assignment section by uploading the document and sharing it to me. So let's go ahead and click this. So once you click the link, it will redirect you to this tab or to this page, and you'll just have to go ahead and click the virtual earthquake. All right, and then these are all information about the entire application that we're using. So virtual earthquake is an interactive web-based activity. You're going to have to understand the concept of how epicenter is located and how Richter magnitude, or a scale of identifying the energy and the damage that could be made when the earthquake happens, will be part of the exposure that you will get after you have done this. So just going over and reading what's a seismogram, what's an earthquake, what is an epicenter, and all of that is already enough information for you to get yourself through each challenge and eventually get a certificate of completion. So yes, you're correct in me when you hear me say that after this activity, the system will issue a certificate of completion with your name on it. So to do that, we have to click on the execute virtual earthquake here. And like what I mentioned, these are all informative resource that you can look into when you're trying to understand further information related to earthquake. So after you have done that, let's just quickly stay a little while on this part of the material. So this is an example of a seismogram. Okay, so the data read by the seismograph. Okay, so in this particular example, you will see different parts. So the beginning here, or the starting point where the wave is detected by the entire tool, is the type of wave called P wave. So the primary wave, the initial wave that has been detected by the seismogram, or that is seen in the seismogram. Now moving forward, the entire time that the primary wave is has been recorded until the entire shear wave or S wave will be collected is what we call, or in between those two types of wave or two seismic wave activity, is what we call the SP interval. Now, it is very important that we know how to identify how long the interval is. This is telling us the possible, shock wave that could be felt on the ground, and that's a large scale example. And that will also tell us in terms of identifying how long we need, or how long we have until we feel the entire earthquake itself. So this graph has some variables such as the time and height. So on this distance, or on the height, we're like trying to measure the amplitude of the wave, and this is telling us how much Richter magnitude, or how much magnitude or energy could be formed when the earthquake is happening. So when we talk about earthquake, it's a sudden release of energy under the ground, and what we're trying to learn there is how much amount of energy has been released. So in this activity, we will have to take down notes about those things. So how do we read the time? Okay, so let's quickly gaze our eyes on the grades, or on the data here. So we say that from here to there is already 10 seconds. And from here to here is already 20 seconds. And as I go ahead and count, that's going to make it 30 seconds. Now, each blue line here for time counts 2. So if I'm going to confirm that, it should be like 2, 4, 6, 8, and 10. 2, 4, 6, 8, and 20. Okay, 2, 4, 6, 8, and then 30. So that's like counting by 2 seconds. So each line is counted 2 seconds. Okay, so when you're trying to measure the time, you got to be accurate. Part of the skill that seismologists needs to have is to be accurate and analytic when they're trying to observe the data found on the seismogram. So to do that, you have to be exactly or accurately counting each part of the gram. So here, we're already on a 30-second mark, okay? And now we're going to try to identify how much more seconds was left before the first S wave had appeared or has been detected. So we cannot say that it's on a 40 because this is already like the highest wave. So it means like the wave has been going on before it reaches the 40-second mark. So we're going to have to try to count exactly the correct interval from the primary wave down to the secondary wave. And to do that, we got to be careful in counting each time in each box. So like what I mentioned, so this is the 10-second mark, this is the 20-second mark, and this is the 30-second mark. Now, in between the 30-second and the 40-second, we see an S wave detection, okay, or the S wave has been detected. So we say 30, 32, okay, 34, and then 36. Now, do I stop here or do I continue? Let's try to match it on our first wave, the second wave that has been detected. So it is detected at the 36 mark. So there were a total of 36 seconds from primary wave to the first secondary wave. Okay, or just from the primary wave to the secondary wave, there were like 36 seconds interval. So that's what we need to remember. Again, the amplitude is the height, which is telling us how much energy is being produced, or that would be the basis of our Richter scale reading later. So, but right now, it's important how to be able to give or provide an accurate data when it comes to reading a seismogram. So we're going to proceed on the next task. So the next task now is for us to see the different location of those seismograms, and that's what we have to look at. So just to give you a perspective from our discussion, so we say that there are 3 possible locations of seismogram centers or seismograph centers, and those were like located in certain areas where, you know, most probably earthquake could occur and most probably seismic wave could be felt. So you got 4 options to choose from, but for the sake of demonstrating how to work on this one, we will choose San Francisco area. So here, I'm gonna go ahead and submit my choice, okay? And this is the map of San Francisco, and you will have to remember that we should see different seismogram in 3 different locations. So we will be dealing with 3 seismogram readings at this time. So we're gonna try to view that, okay, and read it for our own reference, and that will be the basis of the locations of the earthquake epicenter as well. So this task, okay, that we're having right now, we're gonna try to do and view the seismogram in order for us to first predict the time, or not predict, but, you know, read the accurate data when it comes to its interval between the P wave and the S wave. And after we have read the entire interval, we will be able to identify the epicenter. Second, we'll be looking at the Richter scale magnitude, or the amount of energy released when the earthquake transpired. So let's go ahead and do that. So here, we got the first seismogram reading, okay? And what we're gonna do, if you can magnify things like this, like using your fingers, you can like just, you know, zoom out and zoom in the graph so you can read each line properly. So I'm gonna be helping you out. So this one is the first 10-second mark, second 10-second mark. Okay, so that's 20-second mark, 30-second mark, okay, 40-second mark, okay, and then let's count from here: 40, 42, okay, there's still wave, 44, 46, 47. Now you see that the first wave is somewhere there, right? So that is not exactly at 50, okay, because the 50 is over here, but the first secondary wave is like right there before the 50. So we say 48, 49. So it's just 49 because it's before 50. All right. So we move on. Okay, if you did not understand that, how I counted it, let's try this again. This time the second graph. Okay, so we got the first 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds, 70 seconds, and 72 seconds. Again, each blue line counts as 2 seconds. So why I stop at 72 seconds? Because that's where I see the first secondary wave on the 72-second line. Is that clear? I hope it is clear. So once I'm definite and absolutely sure about my counting, I'm going to put it over here as 72 seconds. Now we go on to the next one. So the first 10-second mark, 20, 30, 40, 50, and 60. Now from here, let's carefully count how many more. So 60, 62, and 64. So that first line of S wave is counted at the 64th second mark. Okay, so we write it over here. So it is crucial what you're writing on the second tab or on the second space or on the time space, because you need to be accurate. And that's one of the qualities of a seismologist. You need to be accurate, and you need to be able to analyze your data properly. So once I'm confident that I've counted it correctly, I will just go ahead and convert it into a graph through this button. So there you go. In determining the earthquake distance, you will now be dealing with the distance. So after you have provided a very accurate time interval, we're now going to try to check how much distance it covers. Now this is kind of different because you're going to be in, you know, the closest estimation as you can. Okay, so we're going to look at 49-second mark. Okay, so let's go ahead and gaze our eyes over here. So where is the 49-second mark? It's all the way here. It's before 50. So what is our data, or how much distance it can cover? So this is 300. So each, what do you call this? Each blue line here is a 20 meters distance. So this is 320, 340, 360, 380, 400. 420, 440, 460, and 480, 500. Now our first data says 49 seconds, so over here. So that is kind of like on a 480 exactly, or that is our 49, okay? Because this is our what do you call this, marking. Okay, so this is 41, 42, 43, 44, 45, 46, 47, 48, 49. So this is our marking over here at 49. And seems like our distance is 400 Okay, it's like before 480. So that would be 420, 440, 460. And since it's in between, okay, don't let your eyes be deceived. Okay, so you'll be able to count this one. It could be 480 or it could be before 480. So the quick and the closest or the accurate data matters. So let's say 478. Okay, you can put here 480 if you want, if that is your accurate reading. Okay, but since I'm the one who's reading it, okay, you gotta be careful on the exact seconds or exact distance that you're trying to read. Okay, so we say 72 seconds. So where's that 72 seconds? It's over here. So 71 and 72. And how much distance is that? Okay, so that is on a 700. Okay, it could be on a 705. Okay, or in a 700. Eight, because this one is a 20. Okay, so you can say 705, 708, because it has to be before this one. So the data is in between those black line and blue line. So blue line, if its time is 20 seconds, if its time here is 1 to 2 seconds, and then if its distance is 20 meters or 20 kilometers. So we go ahead and do 64. So where's 64? So 61, 62, 63, 64. So all the way there. And this one is our marking. Okay, let's make that smaller. And that is on a 622. Okay, so we go ahead and do that. And we try to find the epicenter. Oh, see that it is an excellent work. Okay, because the illustration here on the right shows the earthquake region. Okay, and the 3 epicentral circles whose radii corresponds to the distance you determined in the previous document are drawn around the seismic recording station. So you have successfully triangulated the epicenter of this earthquake. So that is, those like little 2 seconds and little 5 seconds matter. So you gotta be very, very accurate as much as you can. So after that, now you have, we can say, compute Richter magnitude. Okay, so how do we do that? This time we're gonna measure the height of the wave. So on the same seismogram, this time we're gonna look into the height to determine how much energy was given off. Okay, so on here, I'm gonna try to see what's the Richter scale. So the Richter scale is saying that it's telling us how much damage could be felt when this kind of earthquake really is found in that particular location. So we're gonna try to measure the height of our secondary wave. So this is 50 meters, 100 meters, 150 meters, 200 meters, 250 meters. Okay, so we say 250 meters, 260 meters, 270 meters, 280 meters, and 282 meters, kind of a thing. Okay, so we say, so this one has a 282 meters. Okay, and then the next one is, this is what, 50, 52, or 51. Okay, because this is like this is 50. So this is 60. So each line here is a 10. Okay, so let me see that. Is that 82? 2, 10, 20, 30, 40, 50. So this is 250, 260, 270, 280, 282. Or 288. Let's make it 288. All right, and then this one is a 60. Okay, so 50, 60, because each line is a 10. And then here we got, what is the amplitude of this one? So we got a 50 and 100, exactly 100. How do I see that is, hold up, let me show you that one. So this is 50, and then that's 100. I hope you see that. Okay, so that's 100. We're gonna submit, and exactly we got the following reading. So the following reading is at 7.1. Okay, because you go 6, 6.1, 6.2, 6.3, 6.4, 6.5. That larger thing is 6.5. 6.6, 6.7, 6.8, 6.9, 7. So 7.1. Okay, so that is our reading here, 7.1. And we try to complete it and confirm the magnitude. And you just had the access to get a certification, meaning you have done a great job. So to enter your name, you can put in here, so your name, the institution is Hunter Huss, and then you say Gastonia, and then you can email me the certificate. So at gaston.k12.nc.us, and then your own email account. Okay, so I'll just put here my own email account then. All right, so when you get a certificate, when you see that congratulations, you've done a great job, that means you had been a good possible future seismologist in this activity, and you just get 100 for getting the certificate. Now, once you're done, you're gonna have to email me the certificate or take a screenshot of it when you see it on your screen like this. So that's my name, Hunter Huss, Gastonia. Successfully completed the required steps for locating epicenter and determining the magnitude of virtual earthquake by the electronic desktop project. So this is today. So these are the data that I have in the activity. Now it's gonna be your turn, okay, to do another location. So you're just gonna choose between 2, 3, and 4. So that's it, and I hope I was able to help you. If you have any other questions, just let me know via email, and I will definitely be able to communicate with you. All right, that's it. Bye-bye.